To open up this new chapter, we're going to introduce the concept of a vector field. A vector field is a function where the input is going to be a point and the output is going to be a vector. And the vector is going to use the input as the initial point. So graphically, what a vector field looks like, and we'll stick to 2 dimensions for purposes of this picture, is that associated with every point within the plane, there's going to be an associated vector pointing in some direction. Now here I'm making the vectors kind of arbitrary in terms of in what direction they happen to point, but this is the idea behind what a vector field is going to look like. Now vector fields are great at associating certain types of flow. For example, if we wanted to consider wind patterns as far as it pertains to meteorology, then every point on the surface of the Earth has a different wind speed associated with it. Now, the way that a 2-dimensional vector field is going to look, we typically use capital F to represent a field. So the input is going to be a point, so in 2 dimensions that would be x and y. The typical notation that you'll see for this is that the 2 components of the vector will be functions as well. P and Q tend to show up pretty frequently as far as those are concerned. In a 3-dimensional sense, the input would now be a point in space, which is why we're going to see f of x, y, z. Additionally, each of your components is going to be a function of all 3 of those variables as well. So in both of these cases, P, Q, and R are known as component functions. So these are just some of the pieces of terminology that we use when defining what a vector field is.